All right, this video is going to cover vectors, specifically displacement and bearings. I'm not going to sugarcoat it. This is going to be one of the most challenging videos that I've made and one of the most challenging videos to understand for you. So do the best you can. Let's go ahead and get started. The first thing you need to know is they're going to be giving you a lot of like on course or bearing or whatever. You need to realize that it's north referenced. So if you think about a compass, it goes northeast, southwest. So like if you had a bearing of, for instance, 30 degrees, you would be going like 30 degrees. So that would be your direction, okay? You're rotating clockwise off of north. So it's no longer like other angles, 30 degrees, you rotate that way and it's there. No, now it's from north. So keep that in mind. That's going to be really, really important. All right, let's just see some examples. The first one, they tell me an airplane travels 1,200 miles due west. So you could start with like an airplane here, and it's going to travel 1,200 miles due west. So 1,200. All right, and then 1,578 miles on a heading west, 60 degrees north. So you're traveling west and you want to go 60 degrees to the north. So what that means is this angle right here is going to be 60 degrees, which makes this angle red 120 degrees. Okay, and you went 1,578 miles on that heading. So this is 1,578. And they want to know the displacement from the start. So displacement is your distance from your start. So like this right here is what they want to know. So this one's actually pretty easy. Since you have the red angle and you have these two sides, you can run a law of cosines. So it would look like this. Okay. And so when you solve this, you'll get that distance, that question mark, to be 2,413.21. So number one was pretty easy. That's nice. The only tricky part on number one was that west 60 degrees north. So they're telling you go west and then do 60 degrees towards the north. That makes that angle 60 degrees. I know that's kind of confusing, but it gets a lot more confusing than that. So let's move on. Look at number two. This person is going on a bearing of 90 degrees due east. So due east for 100 meters. 100 meters. And then they go on a bearing of 180 degrees. Well, that's to the south. And they go 182 meters. Well, luckily for us, that makes a right angle. So this is your triangle. And so you're going to have to go and basically solve this whole triangle. Now, where I would start, they say, what is her bearing from the starting point? Here's your starting point. And then this is your finish point. So this is start. This is finish. When they say what's the bearing from the starting point, they say like, what is this bearing, that angle? So you have to think of like northeast, southwest. It's going to be this angle. So keep that in mind. But let's go ahead and solve this. Where I would start is I would probably go and get this side length. And I would just be using an a squared plus b squared equals c squared. So c squared is 100 squared plus 182 squared. So when you do that, you'll get 207.66. Now, you can either run SOHCAHTOA or you can run law of sines. I'm going to go and get all the angles for this. So I'm going to go get this angle right here. by doing law of sines. So since I know this is 90 and I know this side, I can do law of sines. So it's going to look like this. We'll call this angle A. And its side length oppo is 182. All right, so if you solve this correctly, you will get angle A as 60.09. So this is no longer A, this is 60.09 degrees. Let me fix this triangle. All right, so now that I know that, and I know this angle, I can go get this red angle here, which is going to be 29.91, 29.91 degrees. Okay, so I have the triangle fully solved, so that's a good start. So in terms of her bearing from the starting point, that is, again, you have to imagine it like northeast, southwest. You're going to have to do this entire rotation. So this is where vectors kind of start getting tricky. You know this amount right here. This amount is 90 degrees. So in terms of finding this total one, pink, this total angle, you just add 90 and 60.09. So to get part A, I'm going to do 90 degrees plus 60.09 degrees, which is 150.09 degrees. That's my bearing from start to finish. I hope that made sense. All right, next up, what is the starting point's bearing from her? So she's currently standing here at the finish line. Here she is. I'm not an artist, all right? And so she wants to know, looking this way, what that is. So like think of it northeast, southwest. You're gonna have to do this entire rotation, okay? So it's basically, if you look at it, this picture actually worked out really well. It's basically a full circle, so 360 degrees minus this 2991. I hope that made sense as well. So I'm doing 360 degrees minus 2991 degrees, which is going to give you 330.09, 330.09 degrees. All right. So if she's here, how far does she have to walk? Well, that would be this distance, 207.66. So 207.66, and I think they were talking about meters, they were. And then at what bearing? Well, I'm kind of saying from here to here, which would be the red bearing that we just found, 360 minus the 2991. So I would say add a bearing of 330.09 degrees to get back to the start. I hope that made sense. Okay. Number 3, ship sails for 20 miles on a bearing of 325 degrees. So you need to think about northeast, southwest. This would be 90, 180, 270. So 325 is going to be somewhere like in this quadrant here. So I'm going to go 20 miles at 325 from my start. Here's my start. All right, then it turns and sails at a bearing of 250. So from here, 90, 180, 270. So it's just a little bit less than that. So it's going to go this way. And they go 7 more miles. So it's not that long. It's like this far, 7. All right, and they want to know the displacement from the start. Well, that would be this distance. Okay, so this is one of the problems where it's going to get very, very weird. All right, so here's what you're going to have to do. You're going to have to know if this red line was at 325, so that's 325 degrees. That means this green angle is 360 minus that, which is 35 degrees. Okay, still with me? Now, you go to this point here, and you draw your northeast southwest as well. Okay? This green angle matches this green angle. It's like a parallelogram. So I know this is 35 degrees. And now that I know that, I just need to find this pink angle. Because if I could find that pink angle, I could add these up and have this total angle. So to find that pink angle, you have to remember that this line right here, this one that we drew, was at a bearing of 250 degrees. That means we did all of this and it was 250 degrees, right? Well, this right here is my 180 degree marker. So that means I can do, to get this angle, I can break it up into like, if this total thing was 250, I could break it up into blue, which is 180 of that. And then this other pink portion here would just be 250 minus 180, which is 70 degrees. Let me clean up my triangle. I was just trying to explain it. All right, so this is going to be 70 because this was at 250 and this much of it was 180. So that means this has to be 70. I hope that made sense. So now that I know that, I know this total angle is 105 degrees. And now that I know that, in order to find this blue displacement, I can just run a law of cosines. So that would look like this. We'll call this C. C squared equals 7 squared plus 20 squared minus 2 times 7 times 20 cosine of 105. When you do this, you'll get that C distance as 22.84. I think they were talking about miles. 2284. This green portion of it is going to be a recurring theme in the upcoming problems. Keep that in mind. Okay, let's move on. Number 4. All right, it's this plane, and it's going to fly 847 miles at a bearing of 200 degrees. So here's the plane. And here is 180 degrees, right? If it flew this much. So it's past that. So 200 degrees would be like, my undo's not working anymore. Okay, that's going to be a problem. Anyways, the plane's here, and it flies at 200 degrees for 847 miles. Then it turns, and it goes 80 degrees. So like this would be 90. So it's a little bit less than that. So it's like this, 80 degrees, and it goes 350 miles. So here's my triangle. And they want to know the magnitude of the displacement vector and its bearing. So the magnitude of the displacement vector would be this blue amount, and the bearing, we're going to say it's looking this direction. All right, so that's what we're going to go find here in a second. So if I was doing this problem, I would try to solve for this angle right here first. So let's see how we do this. You're going to have to realize that from this point, let me make this triangle bigger. The bigger you draw your triangle, the better off you're going to be. So it looked like this. And this was 847, and this was 350. All right, now from initial point, it was at 200 degrees, right? This was 200 degrees. Well, here's 180, right? That means this pink portion of it is 20 degrees. This right here is 20 degrees. 200 minus 180. So I know this is 20 degrees. Okay, what that's going to help you with is you go to this next point and you draw your vertical line like so, like an axis almost. This 20 is going to match this right here for 20 degrees. And the next thing you need to realize is this green line was at 80 degrees, right? Well, this whole thing is 90. So that means this right here is 10 degrees off. And once you know that, this whole amount has to add up to 90, right? So it's 90 minus 20 minus 10, which is 60 degrees. So now I have that angle. Now to go get this amount, you're just going to run a law of cosine. So it's going to look like this. We'll call this C. Running out of room, cosine of 60. Okay, that'll work, whatever. All right, so when you solve this, you're going to get this distance, C, as 737.2. Okay, so now you have this spot, 737.2. That's half your answer. You need to go and run law of sines to find these other angles, like red. You'll need to run law of sines to find it. So for example, if I wanted to find the red angle, I would be using sine of blue, 60 degrees over 737.2 equals sine of this angle, we'll call this B, to 847. And so you'll solve this and you'll get angle B as 95.72. So this is 95.72. Then once you have that, you can go get this full angle. So 180 minus 60 and 95.72. That's going to give you 24.28. Okay. Now, compare these. Because this 20 was only this amount of it, not the full angle, which means this tiny angle right here is 4.28 degrees. Okay, so to get blue, to get this bearing, it's 180 degrees to this spot, right? To this spot, 180 degrees. But you have to just subtract that 4.28 degrees because you want this bearing, not the 180 degrees. So it's 180 degrees minus that 4.28 degrees. It's going to give you 175.72 degrees. That would be my answer. So my answer would be 737.2 miles at a bearing of 175.72.